So hi everyone, I'm Lydia. We're going to be covering a lot of ground today. We are going to have a few demos, but there will be plenty of time for questions at the end, so hopefully, there's something for everyone. So I'm Lydia. I am a Google Cloud engineer here at Mantle Group, working in the Google Cloud domain, and I'm going to be talking about infrastructure as code, and specifically Terraform. So what is Terraform? Terraform is an infrastructure as code tool, and it is a description of the resources you want built to house or support your application. So there are lots of different flavors of infrastructure as code, such as OpenTofu, which is open source, or CloudFormation, which is specific just for AWS resources. But today, I'm just going to be talking specifically about Terraform. So what can you build with Terraform? Everything you see here, virtual machines, service accounts, IAM permissions, databases, buckets for object storage, virtual networks, serverless functions, monitoring, alerts, org policies, Kubernetes clusters, user-managed notebooks, basically anything you want, you can get from just about any cloud provider using Terraform. So has anyone here actually used Terraform before? Oh, a few of you, great. And how many have learned an object-oriented programming language like Python or JavaScript? Yep, heaps more, excellent. So you probably already know that those programming languages are executed in order from top to bottom, and they are a list of instructions from you to the computer. And a really key part of that is, so you have to do this and then that, and then you do something else 6 times, and if this, then that. The order of everything is absolutely crucial to make your application work the way you want it to. So Terraform is different. It is a declarative language. You tell it what you want, and Terraform just makes it so. You don't really have to care how it's built or what order it's built in. You just need it to exist, and Terraform makes it exist. So you can actually throw together a single Terraform file with all of these things in any order you want, and Terraform will build it. Now, if you're going to have a human maintain this code, which you hopefully would, you would probably want to break it up into logical files, but you could have one file with thousands of resources, and it just wouldn't matter. Not a great way to do it. I wouldn't recommend that, but it is possible. So what does it look like? So it's a little screenshot of some of my code, something I prepared earlier. As you can see at the top, if it's not too tiny, they are all .tf files. I'm going to call the language Terraform, but the language is actually HashiCorp language. HashiCorp created Terraform. It's now owned by IBM. So you've declared, I want these things to exist. How does Terraform just make it so? Well, first it has to create a state file. Terraform sends its feelers out into the universe, finds out what resources exist at that time, and it creates this file as its source of truth. It then compares this state file to your desired state and makes any necessary changes to make those two states match. So that is, in a nutshell, how Terraform works. So I'm going to do a quick demo for you. So everyone cross your fingers that it all goes well. So, here's some code that I wrote earlier. It's the same code that was in the screenshot before. I'll try to make that a bit bigger. So we have a number of resource blocks here. Each block represents a single resource that we need from the provider. In the first set of quotation marks is the resource type we're building. So for instance, Google Project Service. And then the second set of quotes is the unique identifier for that resource, sort of like the name for that resource, but this is just for use within Terraform, and it can be different to the resource name with the provider. The best practice here is to use underscores instead of hyphens, and to not include the resource type in the unique identifier. People do it all the time, but not best practice. Okay, so what are we going to build? A VM with a custom service account for that VM. So you can see I've got a Google Compute instance, that's their EC2 in AWS. I have this custom service account for use with that VM. And I've written that service account after the VM. And as I mentioned before, if this were an object-oriented programming language, that would be a problem because we need the service account for the VM. But Terraform's smart enough to figure out that we can build that first and then build a VM, and it won't be an issue. So I've also utilized some loops up here. So I've got a for loop. I'm going to be activating some APIs that I'm not using just yet, but I know I will need a bit later in my project. So loops are definitely possible in Terraform. Conditional expressions also possible in Terraform. So, should we build something? Yeah. The first thing we're going to do is initialize Terraform. I realize that's very tiny, so I apologize for that. And what's happened here? The initialization step prepares your environment to make the Terraform magic happen. It downloads the necessary provider plugins, any modules you're using, and if you're using a remote backend for your state file, it makes sure that all of that is in place. So that worked. I see green. So the next step to run is a Terraform plan. This presents to you what actions Terraform is going to take, what it's going to create, what it's going to change, and most importantly, what it's going to destroy. We'll talk more about destroy later. So you do need to read through it carefully to make sure that it's what you want. So what's it going to do? It is going to build the compute instance. It is going to build, it's going to activate 2 APIs. So even though I only described one resource because I used a for loop there, it's going to build 2 resources there, and it's going to build my custom service account as well. So the very last step to make all this happen is Terraform apply. And you will get one more chance to make sure that everything is as you want it. And I will show you before I actually hit yes. These are the VM instances in my project at the moment. There is one that was ClickOps, and we'll get to that later. But we're going to go ahead and say, yes, I would like those resources to exist. And Terraform is going out and making it so. It should take probably less than a minute, I think. So what's happening in the background? It is checking the state file for your current state. It's the source of truth and helps Terraform determine the necessary changes, which should nearly be done. And it's done. So we're just going to refresh this page. And where there was 1 VM, we now have 2. Thank you. It worked. It's amazing. Okay. So we'll just go, I think, back to my slides. So when you run a Terraform command, that state file that I mentioned before is locked. So that is done to prevent overlapping changes. If you're just working on a personal project or a learning exercise, it's fine to keep that state file on your local machine. But if you're going to be collaborating with anyone else, the state file should be kept in a remote bucket. So if you run Terraform plan or apply, that state file is locked, and no one else can run those commands until your processes are complete. So you are welcome to look at the state file, and I will show you on here, but I would strongly recommend that you do not touch it unless you really, really know what you're doing. So I have put mine in a remote bucket, just in case I want to collaborate with this on anyone. And there it is. Just a big JSON file, basically, with all the resources as they exist in the world. So why would you want to use Terraform? Does anyone have any ideas for why you might want to use Terraform? Yes? Yes, absolutely. Automation, exactly. Yes, Lovey?
Cloud agnostic.
Cloud agnostic, yes, absolutely. Anyone else? Yes, yeah. You guys are stealing all my answers. I'm not going to have anything to teach you. So some of the pros. As you mentioned, it's repeatable and automated. If you want one VM, you could go to the Cloud Console or the command line, click a few buttons, write a few lines, make a VM. Great. If you want 6 VMs, you can do that 6 times, or 100 times, or 1,000 times. And every click is vulnerable to human error. So I have absolutely built a VM in the wrong region using ClickOps because I just had it selected to the default. And next thing I know, I've got a VM in Iowa, which is very far away and is going to increase latency when I'm trying to communicate with it. So that's also something that you cannot modify. Once you've built your VM in Iowa, there it is. If you want it to be somewhere else, you're going to have to destroy that and start over. So the difference between building one VM in Terraform or 1,000 VMs is just one line of code. You've also got version control. So if you're going to be building resources in the console or the command line, you're clicking here, there, and everywhere, and then one day it's not working the way you'd expect it to. It was working last Tuesday, but now it's not. So how did you have it configured last Tuesday? Does anybody remember all the clicks they made 3 Tuesdays ago? So maybe you could sift through the logs and work out what it was that you had. That's not going to be easy. It's going to be pretty time consuming, and I wouldn't want to do it. So if you're using Terraform, you're pushing your code to a repo. It's easy to track changes to your environment over time, and obviously making it possible to collaborate with others in a way that you couldn't otherwise do. As Lovey mentioned, it is cloud agnostic. So precious few organizations are dedicated to a single cloud provider. In fact, many argue that it's really not a great idea to do that, putting all your eggs in one basket, as it were. So if you want your Active Directory in Azure, and you want your Kubernetes clusters in GCP, and your object storage in AWS, you can configure all of those resources in one place with Terraform. It is also unambiguous. So as I said, I have ClickOps things into existence just using all the default settings that were available to me in the console. And it wasn't right. There is no default setting in Terraform. You have to know what you want, and you have to be very explicit and write it down in code. And for me, that has been a wonderful learning tool because it forces me to know exactly what it is I'm building. Every step of the configuration I have to know about, or just about, in order for me to build it. So what about cons? Because there are cons. It is provider dependent. So I'd say you could build just about any cloud resource with Terraform, but it is not any cloud resource. Terraform is still dependent on the providers, such as AWS and GCP, to make their resources available through the language. So the maturity and feature set of these providers can vary, and some functionality may not be supported. So a real-world example I had of this recently was building an instance of Microsoft Managed Active Directory in GCP, which was very possible with Terraform, but a key step in the setup is to reset the admin password. And that API exists, but it has not yet been linked up to Terraform. So I had to use my mouse. It was awful. I'm in therapy. I'll be okay. Large-scale deployments. Definitely large-scale deployments do happen with Terraform, but it can get kind of bulky. Checking the state of things and all those resources can take a long time. So I showed you building one VM, one service account, and a couple of APIs, and it took 30 seconds or so. And you can imagine with the large-scale deployments that can add up very quickly. Some of the larger deployments are often broken out into smaller modules to speed things up. Just modify this section of the infrastructure and that section, but this can add to the complexity of the code base. State management. So the state file itself, that big JSON file, you saw how big that was, just for a handful of resources, that can also become very complex, especially in large-scale environments or in dealing with multiple teams. So if you have rogue developers ClickOpsing their way around the console, all their work could be undone the next time you run Terraform. The state file is also just a snapshot. So the only time that it is correct is at the exact moment that it takes that snapshot. If there are any changes that happen between when that snapshot was taken and when your code is applied, you are going to have some unexpected results. Oh. Like that. It's coming back, don't worry. And the final point I wanted to make, another con, is about the state file itself again, and that is about secrets. So everything in the state file is stored in plain text. I might just unplug this and plug it right in. Everything is stored in plain text. So if you have created a password using the random provider perhaps and are storing it as a secret, that secret is going to be in plain text in your state file. So obviously you can control the access of this state file and you can have it encrypted, but it's still not a great idea to do that. And you can use providers like Vault to store your secrets securely. So how do you get started? You want to use Terraform to create some resources. Obviously the documentation, boring. But it is going to be your first stop to make anything like this happen. So Terraform will provide a couple of examples in the documentation. Sometimes it provides a lot of examples. But if you just Google what you want and just add the word Terraform on the end, you're probably going to find what it is that you need. But you also may already have some resources that you've spent hours and hours of your life building in Terraform, and you want to bring it under the control of Terraform. So I'm going to go through how to do that as well. So Terraform only cares about things that you create with Terraform. It does not care what you created with ClickOps. If you've used another method like the CLI or ClickOps, there is no record of that resource in the state file, and Terraform says, not my problem. So what if it already exists? You already have your VM that you or your rogue developer have built via ClickOps, and you don't really want it to be destroyed, especially if you've written to disk. So we're going to go through a quick demo of how to import. That's not what I wanted to do. So we're going to go back to our console, and we have this, that should be done spinning up now. We have this VM that our rogue developer built via ClickOps, and they've put it in Iowa. It's not what we want, but there it is. They've made the instance size an EC2 medium, and I want to bring this under the control of Terraform. So what do? We Google VM, GCP, Terraform. And lucky for us, the first hit is exactly what we need. It's going to give us some examples, and it will list exactly what arguments it needs in order to build this resource. We know at a minimum you're going to have to provide a boot disk. You're going to have to provide a machine type, a name, and a network interface. So those are the only fields that are required to build a VM in GCP. I would add zone as required. It doesn't say it's required, but it might as well be, with a location. And the project as well. Often project is listed as optional. It's kind of not. I don't know why they do that. So we already had this instance though. So I could go through all of these options and all the possibilities and try and work out how it is that we're going to build this VM. But the easiest way to work out what we need to build is to describe. So G-Cloud Compute instance is described, and there will obviously be an AWS and Azure version of this. But this is going to get a description of that VM that our rogue developer built via the console. And I realize this is a lot of text. We definitely don't need all of it. And it's a bit tiny, so I'm not going to make you read all of it. But everything that we need to bring this resource under the control of Terraform is there for us. I have obviously written the code ahead of time, so we don't have to sit and copy and paste. But here we are. Might zoom out a little bit. I realize it's super tiny, but this is describing this. So everything that comes from this description of the existing VM, from the name to the network to the service account, is all listed here, and I've just been able to copy and paste it into the necessary fields. I always start with as few fields as possible when building something in Terraform, and it will tell you if it needs more information when you try to build. So great, I've got my code. And we're ready to build. So I'm going to skip the Terraform init because we already initialized, we've already got our backend, we've already got our providers. We have basically everything we need. So we're going to run a Terraform plan. And what does it plan to do? It's going to create a VM. Great, right? See, no, that's not what we want. We don't want it to build a VM. The VM already exists. We want to bring it under the control of Terraform. So that, even though I copied and pasted everything exactly how it was in the description of the VM, it still thinks we need another one that looks just like it. So that's not very useful. So in order to achieve what we want, we do have to add one more resource block. And that is the import block. The import block takes 2 and only 2 arguments. There's ID and 2. So the 2 argument is the name of the resource within Terraform. We have named it right here. It's a Google Compute instance, and it's named ClickOps. So that's what we want. Google Compute instance.clickops. There it is. And the ID. Now this has to be very specific so that when you run Terraform, it knows this is the exact resource that she's looking for. It's exactly what we want to bring under the control of Terraform. So where do we find that? We could go to the Cloud Console, but we already did a description of this VM. And if we look at self-link, this is exactly what we need. So once again, everything we needed to bring this under the control of Terraform was in the description. And I happen to know that we just need from the word projects on. So I'm going to add that in quotation marks. And we're going to try running Terraform again. Okay, so now we have one resource to import, 0 to add, 0 to modify, and 0 to destroy. This is exactly what we want. So we are going to run Terraform apply. And it will be pretty quick because it doesn't actually have to build anything at all. Yes. Done. And now, both our VMs, both the ClickOps one and the one originally built with Terraform, are under the control of Terraform. So, great, success. Now, the import block that we'd written, we don't have to leave that there in perpetuity. That doesn't have to live there forever. Once it's been imported into your state file, you can delete that. Terraform already knows that it needs to be looking out for it. So you can run these commands, the import command from the CLI, but once again, you're losing that record, you're losing that posterity of what happened when that you're going to need when you're collaborating with someone. I also wanted to touch on a tool that, even though I've been working with Terraform for a long time, I actually only recently discovered, and that is the Terraform console. So you might hear the word console and think, all right, a GUI, I get to use my mouse now, but the console is actually in the command line. So who here has used the print function during when you're writing an application to help you with debugging? So you need to know what's happening at this stage. Yeah, it's all right. You don't always have to use the debugging tool. We all use print to try and find out what's happening at a particular point in our application. So you can't really do that with Terraform because it's not, I mean, you can, but it's not easy. So what are we going to do if we need to know the output of, or the output of a variable? There's no print function, so we're going to use Terraform console. So if we go back to our code, we have a service account here. This Google service account that we've built for the Wick demo VM. Service accounts are usually identified by their email address. So what is the email address for that resource? So we are going to open Terraform console. And that's it. That's the console. It's just the command line. And we're going to write the resource. So Google service account, Wick demo VM, email. And it's going to tell us exactly what the Wick demo service account email address is. Now that seems pretty basic because we've only got 3 resources, but I can promise you in the larger, more complex code bases, this is an extremely useful tool. I use it all of the time. I would also like to point out that as long as you have Terraform console running, your state file is locked. So I'm going to go back to our bucket, which contains our state file, and you'll see there's now a lock file, and nobody else can do anything with the resources under the control of this Terraform. So I'm going to go ahead and exit the console, refresh that page, and our lock file is gone. Which is great. Everybody else can do their job now. So has anyone seen this meme before, other than when I had it on screen 3 minutes ago? Yes? So it is an oldie but a goodie because it is very easy to spend a lot of money in the cloud. Super easy. You can spin up a VM, forget that it's running, and 6 months later you realize that you've just bought Jeff Bezos another cocktail. So when you're learning to code, when you're learning new skills in IT, you're following quick start guides, you're following YouTube tutorials, you're building things, you're spinning up VMs and bots, serverless applications. It's great. It's because the only way to learn how to do this stuff is to do it. So you might remember to shut down some of it, but did you remember to shut down all of it? Because I never did. I originally learned cloud computing on AWS. When I was done with a project or lesson, I'd shut everything down. And then month after month, I was getting stung for $3 here and $6 there. And I do think that Jeff Bezos has enough money, so I needed a better way to manage that. So, the final demo that I'm going to be showing you is destroy. So once again, it's going to look at your state file, update it, and tell you what it is that it's going to do. And it's going to destroy everything. It's going to destroy my API activation. It's going to destroy the ClickOps demo VM. It's going to destroy my Terraformed VM. It's going to destroy my service account. Everything's going to go. So just say yes. One VM's already gone. Oh, or not. It's in a state of flux at the moment. So Terraform will only destroy things that are in the state file, just like it only cares about things that are in the state file. So it's not going to touch any of the resources that are out of that scope. And it will take a few minutes, depending on how much stuff you've built. But this way you won't get any surprise bills. So if you're working on a project and you don't know when you're going to be able to pick it up again, you can run Terraform destroy every hour if you wanted to, and only pay for the resources for the time that you're actually using them. It's taking a long time to destroy this VM. The Terraform destroy is complete, but the VM is still clinging on for, no, it's gone. Everything's gone. So I'm not going to get any more surprise bills from GCP. So if you're going to pick up the project again in an hour, in a week, if you don't know when, this is an absolutely great tool. It's sort of your own personal chaos monkey. Shut everything down and learn how to start over from scratch as quickly as possible. You're also not leaving your resources unmonitored, just waiting for some hacker to build some crypto mining on your VM, which apparently is what happens to like 90-something% of unprotected VMs as they're utilized for crypto mining. Let's see, what else have I got? We destroyed. That's it. That's everything.